Hey everybody, this is Larry. This is me going over Q4 of the bi-weekly contest 58. Whoops. Maximum product of the length of 2 palindromic substrings. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. And if you came here after the contest, come definitely hang out during the Discord, because we're looking, you know, everyone there is very smart and kind of talk about the problems afterwards, and you have nerds like me who are just geeking out about it. So yeah, okay. So this one, the first thing I would say, and the first thing I would notice, is that n is 10 to the 5th. So that means that n squared is going to be too slow, so you have to do something better. The first thing that I realized, and this is a little bit of trivia, and I'm not happy about it, I'm not proud of it, I don't know what to say about it, but you need, for this problem, I believe you need to know the Manacher's algorithm, at least the way I solved it, I did. You can, here's the kind of thing, you can see the link here. Someone will post a link below, but that's something that you can Google on, Manacher's algorithm. But basically it allows you to calculate all the palindromic substrings in linear time, and you need that because n is 10 to the 5th and you cannot do it in n squared time. I'm not going to go over Manacher's algorithm, but the way that I would think about it is that, well, read about it quickly. I'm actually, one thing I would say is that maybe it comes up on competitive, but I would say for me, I believe this is trivia. And what I mean by that is either you know it or you don't. You're not going to come up with this during an interview. And then 2 is that I don't believe this is good trivia, because how often do you do palindromes? You could say that about a lot of things as well, but even more so, I don't know. It's just not worth learning for me, to be frank. And I did not know it during this virtual contest. And if you watch my video afterwards, after my explanation, I actually just Googled it, and you could see me doing it, because I mean, I know enough to know the name of the algorithm, but I just didn't know it that well. Though maybe after today, maybe I learned it, but still, I'm not going to do explanation about this, but the TLDR, because there are videos on this anyway, probably. But the TLDR is that this is just the naive way of, okay, you start from the middle of every character, you expand it out, right? And Manacher is doing the same thing, because if you do it that way naively, it'll be n squared. But what they do is that, okay, it does that expanding out, but it does it in a smart way so that it doesn't pre-calculate, or it reuses previous calculations to skip ahead in the expanding out. So that's the visualization for this problem. Like I said, I didn't know it before this problem, or I knew of the Manacher's algorithm, but I didn't know it during the contest, and I had to Google it. So for an interview, I probably would have failed. But as I said, yeah, I don't believe this to be an interviewee topic. So yeah, so basically I have this Manacher's here, so you can use this as a black box. And then the second question is, and this requires actually learning, or having a deeper understanding of Manacher, and that's basically what I did during the contest is, okay, yeah, let me pull up Paintbrush real quick, but oops. Let me pull up Paintbrush real quick. After these technical difficulties, okay. So basically, the idea behind this one is that, okay, let's say you have you have a string that expands this way. So you have, let's say, A, B, A, C. This is terrible handwriting, but I'm using a mouse to draw this. But the idea is that, okay, you now split it. Let's say you are able to split it in half, right? What is the max palindrome to the left, and what is the max palindrome to the right? And then you just, if you're able to do that scan from left to right, then we take the max from the left and max from the right, we multiply, and then we try to get an answer. And that's basically what I did at the very end. I don't know if you can see it. That's this group, this code here. Don't look at the other code for now. Basically, I look at every possible divide, and then just do the left and right. And the prefix and the suffix thing is actually kind of cute and kind of interesting. Is that okay? So what is this function d of I, right, that you get from Manacher? And I hope you're able to see both. So d of I represents, and this is if you look through this this link as well, is that d sub I represents. Let's say you have d sub. Let's say you're looking at here. Let me change the color real quick. Let's say we're here, right? So d sub I is equal to, so if d sub I is equal to 2 or equals to 1, that means that this number, this character has one character to the left and one character to the right that is equal. So yeah, so you can also do that here. Actually, wow, I actually did a palindrome here. So this one, for example, oops, this one goes actually all the way here. This was actually unplanned. So this would have a d sub I of 3, right? Because it has 3 characters to the left, that's correct, or that's the same as the 3 characters to the right. Okay. So given this thing, so the thing that I did is that I calculate the prefix, right? So what I did is I converted this to a different array where I go, okay, let's say I'm up to this point, right? What is the biggest palindrome that ends here? Yeah, and the biggest palindrome that it ends here is basically I just pre-calculate. So at this particular thing, I go, okay, d sub I is equal to 3, right? So, and since d sub I is equal to 3, then I update this point to contain 7, because that's the length of the palindrome, because that's just 3 plus 3 plus 1 for the length of this subarray, right? So basically, that's my idea here for this prefix. So for each prefix, I look at the d sub I. I set the right endpoint, and then I update the right endpoint to equal to the length of the palindrome, right? Hopefully this part makes sense. I basically converted from an array that gives me the middle to a thing that gives me the end to the thing. Okay. And so the thing that I noticed, and actually I got a wrong answer from this at this particular point, is that, okay, given this thing, so now let's actually do the first iteration of the prefix array by updating the endpoints, right, to the max. So okay, so looking at A, at this point, the A is 0, so we update itself to be 1. The max is equal to 1 here. B here, the max is we update itself again, so we update here to be 1. All right, let's just write on top here. So yeah, so you have 1 here, 1 here. A at this point, at the center, there's 0, so we update itself. At this C, however, you have 3, right? So now we update here to 7. That's basically what I did. Here, this A again, this updates 0, so it updates 1 here. B, you actually have I think I messed up here. Yeah, so B, because for this B, I messed up, sorry. So for this B, I update this, because now it ends here, so we actually update this to 3. And then now for this A, and then for this A, it tries to update the 3 to 1, but it doesn't, right? So now everything is going to be zeros for now, and then for this A, it actually updates, it tries to update this to a 3, but since 3 is less than 7, we keep this as 7, and then now for this C at the end, oh sorry, for this A, we update the 7, nope, and then for the C, we update itself, which is 1, right? So then now you have this array that's 1, 0, 3, 0, 1, 0, 7, 1. The thing that we notice here is, when I was solving the problem, is that, okay, this C, even though, so we have a 7 here, so that means that there's, you know, if you do the math, we know that the middle is going to be here, because now that we're given this array of the end, so what I call this is the endpoint array, because basically this is the max of ending at this point. But it's not completed yet, because here, for example, notice that this C has a length 7, right? So this is length 7, and that's what this represents. But that implies that there's a length 5 array that is 1 length closer. So even though this is 0, we actually want to update this to 5, because we know that there's, you know, by the same logic, that there's a length 5 palindrome that ends here. And same thing, we update this to 3, we update this to 1, and then so forth. I think this updates to 1. Yeah, and all these answers will have minimum of 1, because you know, you always have an odd length of 1, right? So yeah, so that's basically the idea here. So then after this update, we have the array of everything here. So, and then now I do one more pass to get, because now we go, okay, what does this array mean? This array is the, you know, at index I, it means that it ends at that point, the maximum array that ends at this point, the maximum palindrome that ends at this point. Now we want to calculate the prefix of that, which is the maximum array of the maximum palindromes that is of any prefix of this. And we do that by simply doing prefix sum or prefix counting. Okay, so for example, we just look at adjacent elements going from left to right. For example, this is 1, 1, 3, this is good. And here we cross this out and we update it to 3, because 1 is, you know, 3 is bigger than 3, or 3 is bigger than 1, and then we so forth. And for example, we update this to 7 because of this 7, right? So that's basically the idea here. I know that my explanation is very long and it's maybe confusing, but let's go over the code again now with that context, and maybe this is a little bit clearer. But yeah, so basically, first of all, we calculate the right endpoint. Point here. At this point, prefix contains the maximal segment or maximal palindrome that ends at R, right? So we update that with the length, which is this, of the palindrome. And then the second one, we go, okay, we backfill the smaller palindromes, shrinking them, right? So basically, we backfill it by, we look at the smaller one, and we keep, and all in the meanwhile, we keep track of the bigger palindrome, right? So if we shrink them and we have another palindrome that's bigger, then we don't, you know, keep track of it. So that's why we have a max here. And then here we do run the prefix algorithm to contain all maximal palindromes before R, or before I in this case. And that's just regular prefix I. And at the end of this, at the end of all these loops, prefix sub I contains the maximal palindromes before I, or maybe including before or at I, right? So that's basically the idea. Hopefully that is a good explanation, but But yeah, and then basically I did the same thing but in reverse to get the other side of this, to get the suffix. This is exactly the same as we have here, but just keeping in mind that we did everything backwards to go from the left and so forth. And then at the very end, this is as we said, we look at each division of the left and the right, and then we do it this way. Yeah. Cool. This is a very long explanation, but yeah. Okay, so one more thing that I want to point out is that, we only care about, it turns out that for Manacher's algorithm, and actually, I only ran the Manacher's algorithm on odds only. You can actually still use this idea and this algorithm on evens, but it has a lot of weird edge cases, and I think that's why the problem setter made it so that it's odd only, so that makes it a little bit easier and to solve in terms of coding. Because once you get the idea, the even part is actually not that much harder. It's just a lot more edge cases and if statements and weirdness. But yeah, but that's basically it. That's all I have for this one. Let's actually, I keep saying that, but let's go over the complexity real quick. So the Manacher, as we know, this is linear time. Proof in the Googles. Just Google it. And here you can kind of clearly see that this is linear time because we just do 3 for loops. And here we also do 3 for loops, so this is linear time. And you can see here that we also have 1 final for loop to do the multiplication. So this is going to be linear time as well. In terms of space, Manacher is going to be linear space, and also the prefix and the suffix array are linear space. So the entire algorithm is linear time, linear space. Yeah, that's all I have. I'm going to give you one quick look at the code. This is the Manacher part. This is all just Manacher, so I don't, so read up on that one. And here's my prefix and suffix code going backwards. I think if I were doing it again, I would actually have 1 function and then just reverse the array, and then, so that I don't make mistakes here. But luckily I didn't. I did get an off by 1 here though. But yeah, and there you go. Let me know what you think about, and let me know if you have any questions for this problem. And I will see you later. You can watch me solve it live during the contest next. Okay. Q4, maximum product of length. What are we saying? AAA and BBB are palindromes of odd lengths. Oh, what? Non-intersecting what? Maximum product of intersecting of odd length for some reason. And this is 10 to the 5th, so we have to be smart. Yeah. I feel like I need managers or whatever, which I never learned because it's so useless generally. Did people solve this all yet? Wow, people are already done. Good job, Alex. Okay. Not gonna lie, I'm Googling managers right now because I don't remember how to. I don't remember it, so let me Google it real quick. And see if I can use this. not doing a suffix tree, so let's just do string hashing. Odd length. Okay, well that seems pretty whatever, but the rightmost found subpalindrome. The number one. And this thing keeps on saying that this is surprising, but that's fine. Like, too much commentary, maybe. It's too early in the day for me to learn how to do this. Let's see if there's another way. That seems true. I mean, maybe not. I'm not gonna lie, I don't know enough about this because it just doesn't really come up in interviews. But maybe you don't need it. I don't know. Maybe I'm just trying to find about this a little bit too hard. And this code is very short, but I still don't really understand it, to be frank. So we only need odd ones. I guess I don't need to understand this. I just need to figure out the biggest to the left and biggest to the right, and then you just do prefix sum on it. Maybe that's fine. Yeah, let's play around with that. I'm just copying the code a little bit. So this is the naive algorithm. Okay, what does this mean for me? I should put it back up. Okay, so I just basically implemented this. And this is saying that, okay, I guess that's fine. Now we have all these segments. Actually, I'm not gonna lie, at some point I'll do some learning understanding of this. Don't really understand it, but that's fine. Yeah. But then now we can figure out the max at each step. Okay. We can figure out the prefix. Okay, let's do prefix and suffix. These are odd indexes. Okay. So I is equal to d sub. No, wait, okay. So right is equal to I plus d sub I. Okay. This is 4, which is 1 maybe. Oh, this is an I. This is 1. Whoops. 3, 3, 1, 3. Okay. So I think we're good here. So then now we just do the same but for suffix. Oh well, yeah, okay. Now this isn't the prefix, this is length on the back. No, okay, fine. So now we have the prefix thing. So then, yeah. Okay, and then now we have to do the suffix. I think I might miss whatever. That was I plus I minus this I. Is this right? This is 1, 1, 3, 2. Okay, let's remove this part for now, just so I could double check the answers. 1, 1, 3, 1, 3, 3. Okay, I think this is right-ish. Might have to test more. What's the other one? Okay, it goes to 3 as soon as it hits the 4, which makes sense. Okay. And then now we just have to get the max on the left and on the right. Right, so now we have to for loop. So yeah. Max best prefix of I times suffix of I plus 1. I really hope this is right, because if this is not, I don't know how to debug it. Am I good? Let's give it a submit. Oof, like I said, yikes. Okay. That's fine. Maybe should I? I'm thinking right now whether I should have tested it more, but that's fine. I don't know. I'm a little bit lazy as well. Okay, this is all 3s except for this 141 at the end. Did I have an off by 1 somewhere? The entire. Did I miss a palindrome somewhere? Oh, because I could do this and then if this is a whole palindrome, then it's this times this. Huh. Why is my things wrong? Oh, I see. I have to update this in a way that is an n square. Or that is n square. Because basically I only update the endpoints now, but actually it's expanding as we go, so. So we have to do things in a smarter way. Huh, okay. I should test this from okay. Now I feel bad because I definitely should have tested for this. This is the thing that's in the middle. So I update this thing, but I need to update as we're going forward. So how do I do that? Let me think. This should be doable, but I'm not doing it quite right. So you want to do? Okay, so given a thing centered here, okay, let's not do this update yet. Let's point it out real quick. So yeah, so we have all these ones, but actually beyond the middle, it should have like a 1, 3, 5 or whatever. And how do I do that math? Is it true that this, maybe I can just go backwards and this goes to 39 or whatever? Because if this is 41, then that means that this should be at least 39. Is that right? Is that true? I think that's true actually. So let's do that. Let's try that for a second. And then now do it again. Okay. I should have well one function and then delimited this, but that's fine maybe for now. Let's give it submit. Oof. Did I mess up? How did I get 0 here? Whoopsie daisies. Oh, because this is whatchamacallit. Mistakes were made. Silly mistake. Okay, fine. That one was a silly one though. I don't even thought about it, but okay. Hey, yeah, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem. Again, you know, if you came from the contest, we like going through the contest right after contest. So yeah, contest. So come join me on Discord and hang out with me and other smart people. I'll see you later. Stay good, stay healthy, to good mental health. Bye bye.